All right, we covered those two postulates last week, side angle side and side side side, and here's the next three we're going to cover today are angle side angle, angle angle side, and HL is hypotenuse leg. So on page 260, angle side angle congruence says that if two angles in the included side, if two angles in the included side of one triangle are congruent to two angles and the included side of another triangle then the triangles are congruent. So a picture would look something like an angle, a side, and an angle. Do you see how this side is touching both of the angles? That makes it an included side. It's the side in between the two congruent angles. And that has to be the case here. Congruent to an angle, included side, and angle of another triangle. Then the two triangles are congruent. The key is that it has to be the included side. Got it? Page 262. So let's see, let's look at that. All right, look at example 2 on 261 first. And let's see, there's two triangles. And UVWX. And you are told that here's the information that you're given.
Is that a U or?
That's a U. It says determine if you can use angle side angle to prove that triangle UVX is congruent to triangle WVX. All right, UVX. All right, looking at these two triangles, all right, if this angle down here is 90 degrees, then what's the angle on the other side?
90.
It's 90 as well. And both triangles share side XV, don't they? So this side is congruent to itself. So do you have enough information to prove that UVX is congruent to WVX by angle side angle? Do you have an angle, an included side, and an angle congruent to an angle, an included side, and an angle?
Yeah.
You do. So the answer would be yes. There is enough information. Because angle, and if they ask you to explain, the explanation would be that angle UXV is congruent to angle WXV. That the side XV is congruent to side XV. And that angle UVX is congruent to what? Which angle? If we call it UVX in the triangle on the left, what's it called in the triangle on the right? WVX. Very good. Okay? So when you get that question, determine if you can use it. Use angle, side, angle. Yes, you can. Explain. This is the explanation. Those three criteria have been met. An angle, an included side, and an angle. Got it? Now turn page. Angle, angle, side congruence. Angle, angle, side. If two angles and a non-included side. Of one triangle are congruent to two angles and a non-included side of another triangle, then what? Good. The triangles are congruent. If two angles on a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. Angle, angle, side congruence. So the triangle on the left, we'll call it MNO. And QRS on the right. So now it's going to be an angle, and a side that's not in between the two angles. It's called a non-included side. So an angle, angle, non-included side, congruent to an angle, angle, non-included side of another triangle, then the triangles are congruent. So angle, side, angle was angle, included side in an angle, and angle, angle, side is angle, angle, and a non-included side. Good? And the same concept applies to if you're asked, you know, can you use angle, angle, side to prove the triangle's congruent? If you can, it's yes or no, and then explain the reasons. List the angles that are congruent and the side, and make sure that your side is non-included when you're dealing with angle, angle, side. Top of page 263. The hypotenuse leg theorem says that if the hypotenuse and a leg If the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So in a right triangle, the side opposite the right angle is always the hypotenuse. So if the hypotenuse and a leg of one right triangle don't want that. That wasn't a triangle, was it? If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Got to be a right triangle though. Has to be a right triangle. Got it? You don't got it? Anybody have any questions? Jordan, did you have a question?
No, I'm just really lost. Like, I just don't understand. I'm just going to rewatch the video.
Well, what you're going to be asked is if two triangles are congruent. And if you could use angle side angle to prove they're congruent. If you can use angle angle side to prove they're congruent. Or if you could use hypotenuse leg. You just have to remember. Well, you don't even really have to remember the acronyms, do you? Because what else could HL mean? Right? Hypotenuse and leg of one triangle congruent to hypotenuse and leg of another triangle. If those two things are true, then you just list the hypotenuse that's congruent. In this case, AC is congruent to what? Okay, FD. So there's a hypotenuse that's congruent. What legs are congruent? Let's say that BC is congruent to EF. So can you use hypotenuse leg theorem to prove these two triangles are congruent? Yes, you can, because you have a hypotenuse and a leg congruent to a hypotenuse and a leg, and if they ask you to explain, well, here's your explanation. Here's your hypotenuse that are congruent. Here's your legs that are congruent. Okay? If you go back to the angle, angle, side, can you prove these two triangles are congruent by angle, angle, side? As long as an angle, and a non-included side are congruent to an angle, angle, and a non-included side, then you could prove they're congruent.
How is that non-included?
Because it's not in between the two angles. Here, I'll show you. let's say, or let's ask, can you prove these two triangles are congruent by angle, angle, side? Angle, angle, side.
No, oh, I see what you mean by included, because wouldn't that be included?
The one on the left is included, isn't it?
Yeah, but the one on the right.
Is not included. So can you use angle, angle, side to prove these two triangles are congruent?
No.
No, you can't. All right. Those are the type of questions you're going to be asked. Yes.
Alright, so like on the HL one, I didn't know what the hypotenuse or whatever.
Hypotenuse. That's the side.
You kept saying it, but I didn't know what it was.
Do you now?
No.
It's the side that's opposite the 90-degree angle. That's always the hypotenuse in a right triangle.
Oh, I thought it was the box.
The box. It's the side opposite the 90-degree angle. You good?
It's not the box.
Does that make any more sense?
Yeah, it makes sense, thank you.
Okay. Anybody else have any questions or confused? All right, take a look at page 264. Gonna do 4 and 5. Seven and 8. Eleven and 12. Fourteen and 15. And remember, if they ask you to explain, you're going to list the angles, sides, angles that are congruent to each other in order.